Well, as the slide says, the Internet of Everything is inevitable. So I'll spend a few slides trying to argue why that's true. Everything that comes out of my mouth is suspect. So you should be extremely skeptical about anything that I say. But here are some plots that were constructed by other people, so you can blame them if you don't want to believe them. But we've cut the cord. It's clearly I'm stating the obvious here. We're a mobile species now, but when that happened was fairly recently. It turns out that sometime in December of 2001, the number of subscribers to wireless services finally exceeded the number of subscribers to wireline services. That happened only 13 years ago, about this month. That's amazing. So we suddenly became a mobile species at that time. Now, of course, today it's an amazing achievement that we've collectively done as a species. We've managed to sell 4 million cell phones to you every day. That's amazing to me. That number just staggers me. And we use this wonderful technology, this miracle of modern science, to exchange 250,000 completely content-free text messages every second. Hooray for technology. It's wonderful. So already there are more than 6 billion mobile subscriptions out of a population on the Earth of 7 billion humans. So essentially everyone with the power to communicate is able to communicate. In 1981, there were 0. So that's a pretty fast ramp up. In one human generation, we go from 0 to essentially connecting everyone in a mobile fashion. This year, we're projected to actually have the number of subscriptions exceed the global population because some people have more than one phone, business and home. That's an astounding statistic. That means that we really don't have more markets to expand into. Essentially, the only untapped market is babies. And I'm sure there's some marketing genius in some company somewhere figuring out how to connect babies to the net. It's coming. I'm only half joking. I saw a little pop-up recently on a Twitter feed that there is a company trying to get babies to tweet to their parents somehow. God help us all. All right. Now, it's interesting to take a look at the historical path that led to the present, because we might be able to extract some lessons from that history to guess maybe at some possible futures. So it turns out that we can divide the history of communications into 3 broad ages. The first age of wireless was given to us by Marconi, who's often given the title inventor of radio. But if you take a look at what Marconi actually did, he gave us station-to-station wireless telegraphy using spark equipment. You could not send the voice, it was just Morse code dots and dashes. But it was transformative because it allowed for the first time ships to communicate with each other and with a shore. I mean, it's hard to imagine today with our 24/7 connectivity, but it wasn't that long ago when you embarked on an ocean voyage, you were lost to the world until you reached the other side or passed another ship. So Marconi's telegraph changed all of that. And it was an amazing thing. It famously enabled the rescue of the Titanic survivors in 1912. But because it was a station-to-station service and because you had to use this goofy Morse code, it wasn't a personal telecommunications device. You had to hop on a horse and go to the station, give them a message, and some nerd would tap it out in Morse code, and the inverse operation would happen on the receiver side. And so that limited the reach to sort of the kilo scale. But it was important. The second age of wireless occurred kind of by accident. Now, the reason I show this picture is because it shows that there is one constant in humans, and that is the geek gene has not undergone any mutations. I'm sure that back in the Paleozoic era, there was some guy who said, hey, I got this thing called the wheel. It's a really cool thing, and he's bothered all of his friends about the wheel and its many characteristics. Well, here's a guy who was sort of the modern version of the wheel. Edwin Howard Armstrong, he's on his honeymoon, for God's sake. And there's his wife saying, oh my God, I married this guy. He's twiddling the knobs on the first portable AM radio. And it's portable only in the sense that there's a handle on it. Much as my SUV is portable because I put a handle on it. It's the same sort of idea here, but it shows a beautiful sign of what occurred around the 1920s when the Morse telegraph thing of Marconi morphed into this thing where you had a single station reaching out to potentially millions of listeners. Broadcasting was unprecedented. There was nothing similar to it that had preceded it. In fact, the word broadcasting had to be stolen from farmers, where it still means the spreading of seeds. Anytime engineers are stealing language from farmers, tells you that the phenomenon occurred so fast that they were just struggling for verbiage to describe what was already in motion. And so broadcasting was unexpected. It displaced Marconi. He kind of fades from the stage of history at that point. And startups like NBC and CBS start minting money with advertising, a model that seems to succeed well into the internet age. The third age of wireless is what we're enjoying today. People-to-people connectivity. We now go from the mega-scale reach of broadcasting to the giga-scale that we enjoy today. You can call anyone on the planet anytime you want, 24/7. You don't even think about the cost anymore except the parents who are paying their children's bills. And so we've got this 6 billion people connected out of the 7 billion on the planet. It's amazing. So you say, this is glorious. We're actually done with history. We've connected everybody up with this amazing resource. We can find out anything that we want to find out when we want to find out about it. It's an amazing thing. Now, the picture isn't entirely rosy, especially if you were, say, AT&T or Verizon or any of the service providers who have built up all this technology at great capital expense. One of the trends that is somewhat worrisome to some folks is that voice revenue is dropping like a rock while data is going up. And the cost of supporting this is very high. And it turns out that these two curves crossed over sometime in the middle of last year, a much unremarked upon, I think, epoch-making event, where for the first time we became a net mobile digital species. And I think future historians will have a lot to say about the meaning of that particular crossover. If you look at this curve, you get really frightened because the revenue from new subscriptions has plummeted essentially to zero because, again, we've connected everybody who has the ability to speak. So there aren't new markets to conquer, and yet we're constantly demanding, us as customers, we're constantly demanding more services, faster data rates. I want to download the entire season of Game of Thrones in 3 seconds on my phone. And even though our brains are not evolving to be exponentially faster to consume the data, nevertheless, that doesn't ever stop us. So I argue that all of these vectors point to the existence of a fourth age, which actually has already happened. It's already started. We're going to add objects to the conversation. That will enable us to now go from the mega scale to the giga scale to the tera scale. We're going to connect 1 trillion devices in the next, say, 20 years. So just make up a number that's far enough in the future that I'll be retired by then. So you can't come back and say, hey, you were wrong. So it's not just an Internet of Things, which is something that people have been talking about for some time. It's actually the Internet of Everything. It's people interacting with objects as well as objects interacting with other objects. And the architectures of these connections will be webs of webs, nets of nets, nets of webs, any mixture that you can imagine connecting all these things. Whatever makes sense will take place. Now, if you are willing to accept the assumption that we're going to connect 1 trillion devices someday, if you're willing to allow me to be insane, because you have no choice, then you have to look at what sort of things have to occur between now and that glorious future to make that future possible. One of the things is somebody's got to design 1 trillion devices. We have to manufacture them. Take some percentage of 1 trillion devices to figure out how many unique designs are implied by that number, and no matter what percentage you choose, you exceed the number of engineers on the planet. So we have a limitation right there. There's a bottleneck and just an insufficiency of engineers. Now, one solution that Stanford is very well poised to solve is just convert more people into engineers. But there's a limit to even Stanford's ability to make that happen. We have the neurobiologists working on how to reconfigure your brains and everything else to make that, all of a sudden, I want to be an engineer. Yes, we need to. But again, we think there's a limit to how many of those we can actually convert. Another problem is, even a small fraction of 1 trillion devices probably can't be battery powered. Environmentally, it's not going to happen. And humans just aren't going to tolerate having to replace batteries in thousands of devices every year. I mean, for gosh sakes, my smoke detector doesn't get attention as often as it should. So 1,000 devices around my house, they're all just going to be beeping at me until they stop beeping. So that's one problem we have to solve. Another one is if you have 1 trillion devices all interconnected, just think about what that implies. Already, technology has insinuated itself into the very fabric of civilization in such a profound way that we can't imagine life without it. Well, now we're talking about going another order of magnitude or 3 of that sort of insinuation. That means now we become so dependent on this ubiquitous technology that that constitutes a potential risk to civilization. It constitutes a large attack surface. What about security? What about privacy? What about coronal mass ejections from the sun that wipes out electrical stuff? We have to worry about these things now when we talk about deploying electronics on this vast scale. So I'm a glass is half full kind of guy. And so I look at these and I go, wow, this is more fun stuff for my students to work on for the next 10, 20 years. This is fantastic. Now, of course, if you're a glasses half full, empty kind of person, you say, oh, wow, this will be the end of us all. It's somewhere in between those two things. So. Now, what are some possible solutions? These are some of the ideas that we're exploring now, and Professor Horowitz will talk about some of these in his talk. Automated design tools as a workforce multiplier can help bridge the gap so that instead of having a small number of humans try to design a small number of devices, we can have that small number of humans multiply their effectiveness thanks to computer-aided design tools that are another level of sophistication above where they currently reside. We talk about maybe building a device that has the ability to be programmed after it's been manufactured so that you can have individualized functionality that essentially involves a software exercise as opposed to a pure manufacturing exercise. And I'm calling this, just as a placeholder, a field programmable things array. So you build lots of FPTAs, you can pump them out like jelly beans and chocolate chip cookies, and at the end you can have makers as well as ordinary industry personalize these things to have specific functions out of them. Now, how about the battery problem? Well, there's lots of research ongoing at Stanford as well as elsewhere in so-called energy harvesting kinds of ideas, where you can pull power out of the sun, out of thermal differences, out of vibration and so forth. And I'm sure that will be part of the solution, but it's probably not by itself going to be sufficient to enable a compelling swath of applications. So we're now investigating the possibility of using the same base stations that you use to connect to your cell phone network, also to beam power to these devices. So we're going to use remote powering by wireless, sort of the dream of Tesla. And to address the security aspects, we're going to have to do some more work on encryption engines, on security engines. And since security threats tend to evolve, it's a spy, counter-spy kind of thing, you're never done. We'll probably have to have it be flexible in some way so we can upgrade the security engines once we've built them. Otherwise, we'll have to replace 1 trillion devices every single time a new threat emerges out in the field. So there are lots of good, hard problems to work on. I don't think any of these is fundamentally insoluble. It just requires a lot of really bright people to work on these things and solve them. So here's some ideas here, and you can tell that I'm very gifted at art here. So we have a 5G cell tower here powering up these things with power and looking at the data that comes back and pinging them with data. And then you'll have some smartphone that also can communicate with a tower and perhaps directly with the things if they're very nearby, don't have to necessarily hop all the way to the base station and back out again. So there's an architecture here that can get rid of the batteries. Now in terms of the power levels, we're not going to be able to power up a Buick, but we'll be able to power up little devices that sense things, maybe take some video shots, measure temperature, those kinds of things. That can be done on milliwatt power scales, and that's something that's very comfortably deployed and conveyed with a 5G tower kind of idea. What are some of the applications? I'll be honest here, I don't know what are going to be the killer apps. I don't think anyone really knows, but I think it's going to be somewhere in here because I've shotgunned just about the entire space of all things that one would ever want to do. You want to use your cell phone perhaps as a remote control to open your garage door, to sense temperature, to adjust temperature. I'm the kind of nervous Nelly that as soon as I hop on a plane to go to a conference, did I close the garage door? Did I leave the lawn sprinkler on? Darn it, I don't really know. I would love to just be able to pull up a smartphone and look at it. And it tells me right away, oh yes, I did leave the garage door open, press close, bzz, it closes. I would love to be able to do that. So people who just like to track things obsessively, that would be a great thing to have. Of course, you would like to access content for various things. I definitely would like to have a complete monitoring facility in my house so I know when my water heater is starting to drip. So before it floods my basement, I've already got an early warning, and in fact, it's already called the plumber. And the plumber has sent me an email saying, hey, I'm going to be in the neighborhood, and then your water heater's leaking. You want me to just stop by and fix it? Fantastic. Go do that. So I would love to have those sorts of early warning signs just taken care of invisibly without my having to take any real action, just have to respond to a request that's already pushed to me. So these are the sorts of things that are going to happen. Your smartphone will become the dashboard and the remote control for everything in your life that you care to track and that you care to worry about. Healthcare is another huge opportunity here. We're in the century where I think future historians will say, wow, this is the century where bio met electrical engineering and fantastic things happened. And among those will be, you'll be able to monitor your health more or less constantly. I think it's crazy that you see your doctor maybe once or twice a year, and based on that tiny sampling window, they try to infer something about the state of your health. I think it's crazy. It'd be nice to be able to get a continuous monitoring of all the vital stats, establish a baseline, and when there's a delta from your baseline, it triggers some action. It contacts your healthcare provider, say, hey, why don't you come in for a full workup because there's something kind of weird going on with your T2 hormones or something. So an example of what might be able to happen to enable that, there's a company that's manufacturing, I think this is just FDA approved this year, a pill that you swallow, and it's actually activated by your battery acid, your stomach acid. Your stomach acid is the electrolyte for the battery that powers this thing up. And if it doesn't power up, that itself is a sign that there's something seriously wrong with you. So once it powers up, it starts beaming data through your body and to a little vest that you wear that communicates with it and aggregates the data and then beams it to your healthcare provider. So I love the idea that we'll now have these disposable electronics that will monitor important things about your health. That's a great idea. Qualcomm and other companies have recognized the potential opportunities here. I've just shown this from Qualcomm X Prize announcement where they're sponsoring a $10 million prize to incentivize people to think about how to convert a cell phone someday into our best approximation to the Star Trek tricorder. Bones just waves this at you and tells you, oh, you got cancer. But I just fixed it by pressing the green button, and everything is really good now. So that's for the individual level. Having come from DARPA, where we worry about global effects, it also can be useful to know something about, yes, the Internet of Things is talking to me. It's already happened. So the dystopian future has arrived. But massive data collects if we can somehow scrub the data of any personal linkage so that we just get data about what's happening in a neighborhood. Suppose all of a sudden we discover that lots of people in one neighborhood are heading to Walmart for anti-diarrheals. That might be a sign that there's a bad restaurant in the neighborhood, and you might be able to kind of triangulate where the center is, or maybe something more sinister has occurred to the air or the water supply in the neighborhood. And you'd kind of like to have an early warning of that going on and mount a correct response to that. So there's all sorts of global effects that we might be able to extract out of networked intelligence of this kind. So I think there are all sorts of interesting futures. Of course, not all of them will be glorious. Suppose you have a home automation logic that decides to get cranky. You might have an exchange like this, and Hal tells you, I'm sorry, Dave, I can't do that. We've seen that in a movie somewhere, I think, but sometimes movies are more prophetic than we want to admit. I think, again, a lot of the value will come not from the things themselves, but the data they generate and the data that they share in aggregate with all the other nodes. And I think there will be a huge value add from just that data. Now, one of the pushbacks that I often get is, yeah, but can it ever really get that big? Can you really scale to the tera scale? That just sounds nutty. Well, I just point out some stats. The semiconductor business is $300 billion a year. The weight loss industry just in the United States is $60 billion a year, 20% of that. So I think there's enough fungibility here to make that. In fact, if we just convince people that if they ate silicon, they would lose weight and have better complexions, I think right there we've gone pretty much all the way to the future. So we're working on this right now. We have our top people working on it. So in terms of what's the future going to look like, hell, I don't know. But here's some possibilities that people have stood up as good straw man proposals. This one clearly came from a satellite company because everything communicates to a satellite. Somehow I don't think that's the way of the future, but satellites will be around, but I don't think that's the way we're going to go. I think Lockheed probably built this one. Cars are a very interesting opportunity. Already 40% of the value in a car comes from electronics, and it's increasing. And I think that we're going to find wireless networks within cars to allow various accessories to talk to each other, and then allow cars to talk to other cars and to base stations. I think this is coming. Already your cars are instrumenting a lot of things about your engine's health. It would be nice if they could now network that data back to the home planet and say, you know what, you got a misfire in cylinder 3, why don't you bring it in for some remediation, we'll fix that right up and get your gas mileage back up to where it belongs. I think all these things are going to happen. And there are lots of, you just type in Internet of Things into Google and out will pop millions and millions of white papers and slides promising you glorious futures and various other things. And please buy our stuff, those sorts of messages. You're used to that. So if you take a look at all the stuff in aggregate, take a look at the vectors that history is pointing to, you take a look at all the things that we might be able to do that's of value to us that we recognize now, and then sort of take a leap of faith that smart people will figure out even better things to do with it than what we've been able to identify now, I think that you must conclude that the future is extremely bright. So thank you for your forbearance, and talk to you later.